All right, how's everybody doing today, my mathletes? We are going to take a look at Super FRQ number 6, Part K, in this video. So let's take a look at Part K. What does it ask us to do? Well, we've got our integral that's defined by this function here, g of x equals the integral from 1 to x, or 1 from 4 to x of f of t dt, and we've got this figure, our graph here, that's made up of one semicircle and 6 line segments. And the problem we're being asked to find is a limit problem here. No big deal. Find a limit as x approaches 2. And we all know the very first thing that we're going to do anytime you're given a limit problem is, of course, direct substitution. So if I plug 2 in for each one of my values for x, I'm going to get 4 right there. That's going to be 14 and then 10 on the bottom. So this whole denominator is going to end up just giving us 0. Now when I plug in 2 here in the numerator, I'm going to have g of 6 minus 2. So I'm going to figure out what g of 6 is. Now my integral is defined as the integral from, where were we, 4 to, and then we're approaching, let's see, g of 6. So from 4 to 6 of f of t dt. So when I look at my graph here, what I need to do is start here at 4 and then stop over at 6 at this value right here. So let's kind of see what we got. So when I roll the function out, I'm going to end up with this triangle right here, and that triangle is above the x-axis. So when I determine the area for that triangle, I'm going to, the net result, I'm going to have a positive value. So what is the area of said triangle? Well, I've got a base of 2 and a height of 2, so that means that area is going to be 1/2. The base is 2 and the height is 2, so that product is going to give me 4, but then when I divide that by 2, I'll end up with just plain old 2. So g of 2, or that part g of 6, is going to give me a value of just plain old 2. So g of 6 is just going to be 2, that value that we got from there. So when I plug 2 in here to my numerator, oh boy, look what happens. So this, we just figured out that part's 2, which means 2 minus 2, so the numerator is also going to be 0. Oh boy. And anytime we got some L'Hopital, you've got to make sure that we just take the derivative of the top and the derivative of the bottom. So let's go ahead and do that right now. So we'll still make sure you keep your notation solid, so don't drop the lim as x approaches 2 part. Make sure you have that. Now the derivative of the numerator is going to be g prime of 3x, and then don't forget, because we've got the chain rule, so the derivative of 3x, I'm just going to write the 3 in front there. So we've got 3x, or 3 times g prime of 3x in the numerator, and then the denominator is going to give us 2x minus 7 when we take its derivative. So this time when we plug 2 in, again, we'll get 6 for the right in here, so we're going to have g prime of 6, and then we're still going to have 3. So 3 times g prime of 6. When we plug 2 in the denominator, we're going to have 4 minus 7. So the denominator is going to give us, what, negative 3. Now at the top, I've got to figure out what g prime of 6 is. So let's just kind of review some FTC stuff here a little bit, right? So if g of x is defined to be our function from 1 to x, or 4 to x of f of t dt, then that means g prime of x is just going to take us right old back to our plain old function, f of x. And it's f of x because there's no number in front of the x, so like if that was 2x, then we'd have to stick a 2 there. But that is not the case here, because we would need to use chain rule if there was a constant in front of the variable there. So let's evaluate then and figure out what is g prime of 6. So we're going to plug 6 in, right, anywhere there's an x. So g prime of 6 is just going to be f of 6. Now f of 6 just means, hey, I got to figure out what the y value is. So I go over to my function that is defined, I've got my piecewise function here, and I have to look at the y value at 6, and my y value right there, let's kind of zoom out a little bit so you can see there. So my y value is just 2. Okay, so this has a value of 2, so when I plug 2 in up here, I'm going to have 3 times 2, which ends up just giving me 6. So I'm going to have 6 in the numerator and then negative 3 in the denominator, and 6 divided by negative 3, of course, is negative 2. So that is the value of the limit as x approaches 2 of the function that we are defined right here to have. So now in the AP exam, Points-wise, you'd get, most likely, you'd end up with a point right here for correctly applying L'Hopital's rule to the indeterminate form that we got when we used direct substitution, and then you'd get a point for the answer right there. So this would probably be worth 2 points on there. So just make sure you take time and evaluate everything correctly. You find your derivatives correctly, you apply the FTC correctly, and of course you do your arithmetic correctly. Now again, AP style, you could actually just leave that right there and that would be okay. Or you could simplify there, or take it all the way down to -2. Either way, your answer is numerical, so you would be okay. All right, thanks for watching this video, my mathletes. I will catch up with you later. Peace out.